This first chapter describes basic FX options and familiarizes you with the standard terminology for defining options and also with the principal mechanics thereof. An FX option is a contract that gives one party, the buyer, the right to purchase from or sell to the other party, the seller, a defined quantity of one currency against delivery of a defined quantity of another currency on or before a specified date in the future. The right to purchase is referred to as a call, while the right to sell is referred to as a put. If the right to exercise the option arises only on the last day of this period, the option is said to be a European option. While if the right to exercise the option arises on any day at all during this period, the option is said to be American. The date on which the right to exercise lapses, i.e. terminates, is called the expiration date, and the option's time until expiration is referred to as its maturity or tenor. The price per unit at which the two currencies will be exchanged if the option is exercised is called the strike, and the amount of each currency that will be exchanged in total is called the notional amount, so that strictly speaking an FX option has two notional amounts, one for each currency, a little bit like a cross-currency swap, which is covered in our module on interest rate swaps. Finally, the premium is the price paid by the buyer of the option to the seller in return for acquiring the option. Unless otherwise specified, the premium is paid up front and should carefully not be confused with the money exchanged between the buyer of the option and the seller of the option if the buyer chooses to exercise the option. The table you see here provides the principal terms of a typical FX option. The name of the option is sterling call US dollar put. The notional amount is 10 million sterling. The strike, $1.5. The trade date, January 1, 2009. Expiration date, July 1, 2009. So this is a 6-month option. Style, European, exercisable only at maturity, and premium paid up front of $250,000. Note that we have specified only the notional in sterling, but you can calculate the notional in US dollars simply by multiplying the 10 million sterling notional by the strike of 1.5 to get $15 million. Note also that the name of this option was written above as sterling call US dollar put, which reflects an important reality for any FX option. If the owner of this option chooses to exercise it at expiration, he would receive 10 million pounds, so he is purchasing pounds for a price of $15 million, Hence, we can view the option as a call on sterling. But it would be equally valid to view this exchange as involving the sale by the owner of $15 million for a price in sterling of $10 million. Under this interpretation, the owner has bought a put on US dollars. So, a call on sterling against US dollars is also a put on US dollars against sterling. To avoid confusion, you should initially describe any FX option using this dual terminology, but in practice, people who trade options frequently end up dropping one of the two possible labels depending on the custom in the specific market in which they are active. You should finally realize that the owner would not exercise this option at expiration unless the spot price of sterling on that day is higher than $1.5. If it is lower, he would be better off, obviously, purchasing sterling in the spot market at this lower price. This does not mean that the owner of the option must wait until maturity to see whether he has a gain or loss under the option, but may simply sell the option in the secondary market if market factors have changed in a direction favorable to him. This worksheet, long call, graphs the value of the option expressed in US dollars for the holder at expiration, plotted against the spot sterling dollar rate on the expiration date. This graph ignores the payment of the upfront premium and shows only the value of the option on a standalone basis at expiration. Sometimes the premium is included in the graph, which has the effect of shifting the entire graph down by the amount of the premium, as shown in this second graph appearing right below the first one. But you should recognize a minor inaccuracy in the second graph, since no time value difference is drawn between the premium paid up front and the payoff at maturity 6 months later. Because the majority of FX options are short-dated, this difference is small and is therefore usually ignored in these graphs. We can proceed to draw similar graphs for the other three principal option positions a user can have. In each case, the underlying currency being assumed to be sterling and the other currency the dollar, and the strike being held constant at 1.5. In addition to long call discussed here, we have long put, short call, and short put. We will turn in just a second to the graphs for these, but first a little terminology. Long call means obviously owning a call. Long put means owning a put. Short call means selling a call, and short put means selling a put. This last one, selling a put, can be a little confusing to beginners. The user is selling to the other party the right to sell a currency at a defined strike price. If the option is exercised, our user will find himself receiving sterling and being required to deliver dollars. Some people find it difficult to understand how, when the user is selling an option on sterling, he ends up owning sterling if the option is exercised, But of course, this is correct since the option the user has sold gives the counterparty the right to sell sterling, which the user ends up owning when the option is exercised. In a sense, the two uses of the word sell turn the user into a purchaser of the underlying currency, sterling in this instance, rather in the same way that two negatives turn into a positive in basic math. Worksheet long put shows the payoff at maturity for an owner of a European put option, first excluding and then further down on the worksheet including the upfront premium, which we have assumed once again to be $250,000 for simplicity. Note that the shape of the graph is similar to that for long call, but of course the gains arise when sterling falls below the strike rather than when it rises above it. To be precise, this graph is the horizontally symmetrical one to that for long call, meaning that you simply flip the original graph left-right to obtain the new graph. Worksheet short call shows the payoff at maturity for a seller of a European call option, first excluding and then further down the worksheet including the premium. This time the shape of the graph is the vertically symmetrical one to that for long call, meaning you flip the graph for long call upside down to obtain the new graph. Worksheet short put finally shows the payoff at maturity for a seller of a European put option, first excluding and then including the upfront premium. Not surprisingly, the shape of the graph is the vertically symmetrical one to that for long put, meaning you flip the graph for long put upside down to obtain the new graph. You should have realized from looking at these graphs that while the potential gains for the owner of a call option are unlimited, the maximum gain for the seller of a call option is the upfront premium, multiplied obviously by the notional for a total dollar amount. Put options are a little bit more confusing. The seller of the put, once again, can gain no more than the premium he collects up front multiplied by the notional. But in the case of the owner of the sterling put, this party reaches his maximum gain of $15 million if sterling undergoes a dramatic devaluation and becomes essentially worthless against the US dollar. If, however, we were to express this gain in sterling, we would divide this $15 million gain by the spot rate, and our result would get infinitely large as sterling became worth less and less. If we ignore this last subtlety and agree to always express the outcome for all four positions in US dollars, then this simple table summarizes the maximum upside for each of the four basic option positions.